Hello, geometry students. Today we're going to continue our discussion of surface area of solids by looking at the figures that have only one base. Those would be the pyramids, and then of course this special kind of pyramids, the cones. Copy down the title as well as the objective, and our objective for today is to learn to calculate the surface areas of pyramids and cones. As always, anytime you need more time to copy something down, press pause and then hit play when you're ready to move on. Now, we're going to probably find it a little bit easier to work with some things today because finding the surface area of pyramids and cones is slightly different than it was with prisms. Since all pyramids and cones have certain properties in common, we have formulas that we can work with. Now, last time with the prisms, we didn't have a whole lot of formulas because there was so much potential variation from one prism to the next. However, pyramids have more commonalities to them, and that's going to allow some formulas to come into play. Okay, so let's take a look. The surface area of a pyramid or a cone. It comes equipped with a formula. I actually have two formulas on the screen here for you, but they are the same formula in two different versions. The formula is 1/2 PS plus big B. Or another version of it is 1/2 PL plus big B. Now, what's the difference between the two formulas? Obviously, there's only one thing that is different, and that is one of them has a little s in it, the other one has a little l. Now, as you can probably guess, little p is perimeter. Okay, so that's going to be perimeter, and the perimeter is referring to the perimeter of the base. Okay. The difference between the two formulas is S and L, and the difference between those two is the vocabulary difference that we talked about, and that is slant height versus lateral height. Okay, well, we've already talked about that those terms are kind of interchangeable, but they mean the same thing, obviously. Okay, slant height and lateral height, and then big B. Okay, big B is the area of the base. Now you'll run into big B in other formulas from time to time. It always represents area of the base. Now, there are such things as pyramids that do not have regular polygons for bases. For example, some of them might have a real rectangle on the bottom, meaning one side's larger than the other, or possibly a trapezoid on the bottom, or maybe even just a quadrilateral that doesn't have any particular properties, stuff like that. But for our purposes, we are going to be only looking at pyramids that have regular polygons for bases. Okay, so that's going to uncomplicate things a little bit for us. Now let's take a look. Find the surface area of the rectangular pyramid shown below. Now, I just said a moment ago that sometimes pyramids may have actual rectangles for bases, okay, but I also said that the ones that we're going to be looking at have regular bases. So when we say a rectangular pyramid, in this particular case, we are of course talking about a regular rectangle, which would be a square. Okay, so it's going to be a square base on the bottom. Anyway, once you identify that you have a pyramid and that you are looking for the surface area, we of course have a formula to go along with this. The formula that I typically think of when I think of surface area is the 1/2 PS plus big B. But if you like using the 1/2 PL for lateral height instead, that's fine, go right ahead. 1/2 PS plus big B. There are three unknowns in this formula. We need to know the perimeter of the base, we need to know the slant height, and we need to know the area of the base. Okay, so those three variables, if we do not have them, we're going to have to find them first before we'll be able to plug in. So let's take a look here. Let's just start off with P. What is the perimeter of the base? Now, the problem didn't come out and hand us the perimeter. However, they gave us enough information to easily find it. We have a side length of 10 on our base, and we know for a fact that our base is going to be equilateral. So it'll be the same four sides on all sides of our pyramid. So we have a square base. All of the sides are the same. So those 10 units that we know, there are four of them. So clearly our P is going to be a 40. Now that's not the answer. That's just a value that's going to get plugged into the formula before we're done. Continuing on, okay, S, we need to know the slant height. Well, let's look back at the picture real quick. Did we have the slant height in the picture? We have the real height in the picture, but we do not have the slant height. Okay, so just like many other things that we have come across through our travels in geometry, if we have an unknown value that we need to know, one of our main things is to build a right triangle using this unknown location, and then see if maybe we can't do Pythagorean theorem or SOHCAHTOA or something like that to help us find it. Okay, so if we add in a couple of measurements, namely the apothem as well as the unknown slant height, you'll see in our triangle that or in our pyramid, we have a nice little right triangle inside of there using the height and the apothem and the slant height. Now the apothem was not given to us as 5 units, but of course the apothem goes from the center of the pyramid directly over to the side. So that would be half of a side length. There you go. 10 becomes 5 for halfway across. Now we can of course run the information through the Pythagorean theorem. Hopefully you already know that that hypotenuse is going to be 13. This is a 5, 12, 13 special right, not special right triangle, but Pythagorean triple. Okay, but you can work your way through the Pythagorean theorem in order to discover that it is a 13. But at some point in time, you might want to get this triangle memorized. He shows up a lot. Okay, so there's our S value. That is not the answer, but we will plug it into the formula before we are done. So moving on. Big B, what is the area of the base? Well, of course, we know that our base is a square. Okay, and we have a formula for the area of a square, side squared. All we need to know is the side length, which we know is 10, and 10 squared is 100. Okay, so there is big B. That's not the answer either, but it all is going to get plugged into our formula. Okay, we found a perimeter of 40, we found a slant height of 13, and now we found an area of the base at 100. Please remember your order of operations. You absolutely must do the multiplication before the addition, or else you will miss the problem. Okay, so we're going to combine the 1/2 and the 40 and the 13 to get 260 before we finally add 100 to that to get 360. There were no units of measure provided for us in the formula or in the problem, but whatever the units of measure were, they would have been squared. 360 square units. Okay, now obviously the only thing that can really change in our pyramid is the shape of our base. Okay, so once again, surface area, pyramid, we have a formula, 1/2 PS plus big B. Okay, so all we're going to do is start walking through our formulas again. Okay, P, perimeter of your base. Okay, well, it is a triangle, and we said that our bases will all be regular figures, so it's going to be a regular triangle. All right, so that's 6 units on the side of the triangle. There are 3 of them equal going around the triangle, around its base. So we're going to have a P of 18. Slant height, look back at the figure real quick. Do we have the slant height in this case? Yes, in this case we do. They did provide us with the slant height, so straight out of the figure, S is 5. Big B, area of the base. Okay, well, our base is a triangle, so of course we find the area of a triangle by our triangle formula, 1/2 times base times height. Okay, so we're going to need to know what's going on with our base. Now here I've just kind of taken a two-dimensional look at the base. We know it's 6 units on each side, so that's very easy to plug into our formula as a base measurement, but we need to know the height perpendicular to that base. Now there's a bunch of different ways to go about this. It is, of course, a regular triangle that is being bisected by the height. So that makes this two 30, 60, 90 right triangles. We could use those rules, or we can use Pythagorean theorem. Either way, okay, to find the height, so just plugging in our values, either by this method or by the rules for 30, 60, 90, we're going to get a height that's in the ballpark of 5.20. Okay, that is the square root of 27. Okay, so now you have all of your values. All you have to do is plug it into your formula. Or I'm sorry, we haven't found the area of the base yet. We had just found the height of the base. So now taking that information and plugging it in, we knew we had a base of 6 units. And our height of our base is in the ballpark of 5.20. That gives us a big B of 15.59. Now, finally, back to the formula, 1/2 PS plus big B. All we have to do is plug in our numbers. We had a perimeter of 18, we had a slant height of 5, and we had an area of our base of 15.59. Please excuse my dear Aunt Sally, got to do the multiplication before the addition. Okay, so on the left side, 1/2 times 18 times 5 is 45, and that must be done before you can then add 15.59 to it. So that gives us a surface area of 60.59, whatever the units are, squared. Now I think you get the idea, but we're going to go ahead and take a look at our friend the cone. He's a little bit different because he does have a circular base, but that does not change the fact that he is still a pyramid. Okay, so since it is a pyramid, same formula still applies. Surface area equals 1/2 PS plus big B. Okay, changes our formulas a little bit because when we start looking for things like perimeter of our base, well, our base is now a circle. So that's going to make us change our formula a little bit. We need not necessarily perimeter, we need circumference. And the formula for circumference is 2 pi r, or some of you learned it as pi d. Either way, that's fine. Okay, and so we need to plug in the radius into this formula. Now they gave us the diameter as 24 units, so half of that would be 12. So plugging into the formula, we end up with a decimal in the area of 75.40. It is okay to go ahead and convert it to a decimal, or you can leave it in terms of pi. It would be 24 pi. Either way is fine. Okay, so there's P. Now moving on, we need to know the slant height. Quick glance back at the problem. Did they give us the slant height? No, they didn't. They gave us the overall height, and they gave us information about the base. Okay, but we can set up a formula, a Pythagorean theorem, with the slant height, 12 squared plus 30 squared plus slant height squared. Where'd we get the 12 from? Well, 12 would be halfway across the pyramid. So your radius would be 12, your height is 30. Those are the two legs of the triangle, 12 and 30. So plugging them in, solving the Pythagorean theorem, we get the square root of 1044. Okay, that is in the ballpark of 32.31. Next, big B, area of the base. Of course, our base is a circle, pi r squared, so all we need to know is the radius. Well, we've said several times already that our radius is 12, so plugging that in, we're going to get 144 pi, or a decimal in the area of 452.40. Now, the reason I said it's okay to go ahead and go to decimal points is because we're ending up with a lot of decimal points, so we might as well just be able to combine them. But lastly, plugging into your surface area formula, 1/2 PS plus big B. Our perimeter was about 75.40. Our slant height was about 32.31. And our base, area of our base was about 452.40. Please excuse my dear Aunt Sally, you must do your multiplication before your addition. So combining everything on the left first before the right, and in the end we get an answer of 1,670.49 square units. It is not that difficult, same procedure over and over again. but that is how we find the surface area of a pyramid. I appreciate you finding time to get your notes taken care of. I'll see you in class.